lecture, we are going to talk about management principles for process management. These principles relate to managerial practices and logics that support the adoption of process orientation in a company. In particular, there are three principles belonging to this category: process documentation, process measurement, and process flow optimization. Process documentation is a principle that focuses on the need of sharing and spreading knowledge on the process within a company. In fact, to properly manage a process, we first need to understand how the process works, which are the organizational units and positions involved, and which are the responsibilities on the different activities. Then, we need to spread and communicate this information to the members of the organization. But how can we put in place this principle? First, we can map and model the processes with formal languages and software to represent the processes at different levels of details. Second, we can create a process repository, which is a collection of documents describing the different processes in details. Third, we can use official communication channels, for example, company intranet, to share those documents and allow everyone to access to them. Process documentation is fundamental for process management for several reasons. With this process, in fact, we can summarize the process responsibilities thanks to the end-to-end overview of all the processes. We can gather and codify data needed for the proper management of the process through a formal standard shared by all the people in the company. And finally, we can support process management and process improvement. The second management principle is process measurement. The key point of this principle is the definition of the objectives of the process in order to identify key performance indicators and so measure the process to be able to manage it properly. Which are the levers to put in place in order to do so? We can use dashboards of indicators that measure the key performances of the process. The key performance indicators need to be linked to the critical success factors for the company and should be referred to the operational performances of the process, not of the performances of the single units. We talk about different categories of process performances and how they are interrelated of each other in two dedicated lectures. It is important to underline that for process measurement principle to be successful, the company should also have a coherent pay-for-performance system related to the evaluation of performances of the members of the organization, linking the incentives and bonuses with the key performance indicators of the process. To summarize, the goal of this principle is, of course, to measure the performances of the process both from a strategic and operational point of view, to put in place a management control system that is process-oriented and not functional or divisional oriented, and to help identifying a set of incentives and bonuses which are coherent with the process orientation. The last management principle is process flow optimization. The key point of this principle is to design the flow of activities performed by the company in a process-oriented sequence. In other words, this principle suggests to simplify the sequence and the flow of activities which are too fragmented or too complex, because, for example, they are carried out by different positions in different organizational units in a not linear flow, in order to facilitate the process orientation and management. Which are the levers to put in place? First, redesign of workflow of the process by eliminating not adding value activities, simplifying the sequence of the activities as much as possible by putting them in parallel or in overlap, or standardizing some activities. For example, we could simplify and standardize the activities related to the taking in charge of the order by the final customers, or administrative exchanges of data between different organizational units. We can also decide to standardize some activities, balancing the pull and push logics. What's the difference between these two logics? Managing a process with a push logic implies that the process is started on the basis of the forecasts about the requests of the final customer. Company therefore start realizing the activities before the formal order or request by the final customer. For example, a company in the automotive industry could start producing certain volumes of a specific model based on the forecasts about sales for the next 4 months. Adopting a pull logic instead implies that the process is started only after the formal order or request by the final customer. For example, a company producing cruise ships can start to produce the specific model of a ship only after the formal order by the final customer, indicating all the specific requirements. With a push logic, the process can usually guarantee a shorter response time of the process. With a pull logic instead, the process can usually guarantee a higher level of customization of the final output. Of course, both dimensions, response time and level of customization, are important. Thus, process flow optimization principle suggests to find the proper balance between the push and the pull logic by finding the proper decoupling point. The upstream activities of the process can be carried out with a push logic, while the downstream activities can be carried out instead with a pull logic. For example, a company can decide to start producing and stock some parts or modules of the final product following a push logic. Then it will start assembling the final product only when they receive the formal order by the final customer, adopting a pull logic in order to satisfy all the requirements of the customer. The optimal decoupling point of the process is the one that balances response time and customization according to the desired level of performances. For all these reasons, process flow optimization principle helps in creating value for the final customer and in improving both efficiency and effectiveness of the process.